Hello everyone, I'm Kathy. When routing high-frequency signals on rigid flex PCBs, do you constantly worry about impedance transitions at vias and signal loss? Let me show you how to optimize them. 1. First, optimize via structure. Minimize cross-sectional transitions. Impedance transitions at vias often stem from poor structural matching. Match via diameter to high-frequency trace width, for example. Pair 0.2 mm traces with 0.3 mm vias. Avoid overly large holes that cause sudden cross-sectional increases. Expand the counter pad, the blank area around the via, to prevent nearby copper from interfering with impedance. For flex vias, balance counter pad size between impedance control and bendability. 2. Calculate impedance accurately. Match signal requirements upfront. Don't design by guesswork. Calculate impedance precisely before implementation. Use PCB design software, for example, Altium, to calculate via impedance, ensuring it matches the impedance of high-frequency transmission lines, typically 5075, or vias in flexible sections. Accounting for impedance changes during bending by incorporating substrate elasticity parameters in calculations to prevent abrupt impedance shifts after flexing. 3. Add shielding or use specialized vias. Block interference loss. High-frequency signals are susceptible to interference. These steps address vulnerabilities. For critical vias, for example, RF signals, surround them with ground vias to form shielding, reducing impedance fluctuations caused by external interference. In high-frequency scenarios, prioritize blind or buried vias over through holes. They minimize exposed metal surface areas, lowering the probability of impedance discontinuities. Rigid areas in rigid flex designs are ideal locations for blind or buried vias. In summary, high-frequency via optimization focuses on 3 key points: structural matching to reduce transitions, accurate impedance calculation, and adding shielding or using blind or buried vias. Following these steps significantly reduces signal loss, ensuring stable high-frequency performance on rigid flex PCBs.